Okay, here are the notes for section 1.2. 1.2 is all about graphs and lines. So we start off with the definition of the graph of a function f. It's the set of all points x, y that line the plane that satisfy the equation y equals f of x. Here these are ordered pairs. All of the ordered pairs, the x's and the y's, satisfy this equation. Again, this is in function form, f of x, and then y is the y that you usually see in an equation. Let's talk a bit about linear functions. There's a little some bullets that happen to be true about linear functions. The graph is a line, first of all, and in function form, I'm grabbing this highlighter, looks like this. F of x equals mx plus b. That's in function notation. The equivalent equation form is right underneath, y equals mx plus b. If you notice from over here that y and f of x can be interchanged. So this is equation form here, up there, and the highlighted in blue is the function notation. But for this to be a line over here, m, that coefficient to x, is your slope, and the b is your y-intercept, where it crosses the y-axis. Alright, so the m and the b, those are pretty important for linear functions. Alright, so to start off with, what we're going to do is, given these are in equation forms, you can see the y's in there, identify the slope and the y-intercept. So for part A, we can kind of already see that it's in this form, y equals mx plus b. If your equation is already solved for y, if you have the y on the one side all by itself, then your coefficient to x on the other side is your slope. So here, m is a negative 2/3. Now we're going to have to do some work for part B down here. But this one's already done for us. Here's my m, there's x plus b. So my b is actually a negative 1. That's okay. Your b might be positive, might be negative, it might be an integer or a fraction. The y-intercept can be a fraction, that's okay. Let's see what happens for part B. Look at part B. It is not in slope-intercept form. We'll get to that later. It's not in the y equals mx plus b form. So all we have to do is solve this for y. So let's add the 3x to put it on the other side. Then if we divide through by 4, we'll have, we'll have it solved for y. Since it's solved for y, you can see it's in this form. Y equals mx plus b. So I can readily pull off my slope and my y-intercept. The slope is always the coefficient to x on the other side as long as it's solved for y. That equation, solve it for y first. Coefficient to x is your slope. Here we had a 3/4. And that constant term, whatever it comes out to be, is going to be your b, or your y-intercept, where it crosses that y-axis. That's really important when you're graphing these linear functions or just looking for, the slope and the y-intercept. Put it in this form, solve it for y. If it's solved for y, it'll be in this equation form. M is that coefficient to x, that's your slope, and b is that y-intercept. Right, that's if it's given in equation form. But calculating a slope, if they give you 2 points, what if they just give you, alright, let's be given 2 points. Here's an x1, y1, that's the first ordered pair. Here's my second ordered pair, an x2 and a y2. Alright, to calculate a slope here, you may remember rise over run for a slope. Alright, all you're doing, the rise represents the change in the vertical positions. So those are the change in your y coordinates, y2 minus y1. over the run is the change in the horizontal direction. So x2 minus x1. All right, here we don't want the x's to be equal, or we'll be dividing by 0. So that's how I calculate a slope. If they give you 2 points, here's my first ordered pair, my first point. There's my second ordered pair, my second point that they give us. Then all you do is subtract the y's. You know, you come up with the same slope. Doesn't matter. I like to calculate it actually y1 minus y2. Then down below you have to do x1 minus x2. Alright, you can switch them around, but just make sure whichever y coordinate that you start with to subtract up top, you have to start with that corresponding x down below. You still don't want those two to be equal. You don't want to divide by 0. Okay, either way you want to calculate it, it'll come out exactly the same. Okay, so let's try it down here for this next example. Let's just calculate these slopes for part A, and we'll do one for part B. Alright, slope is always denoted with a lowercase m. So what I'm going to do, I always, again, start with that first y and subtract the second one. It doesn't matter, but I'm going to start with 0 minus 2 on top. That's subtracting the y's. Make sure you start with those y's on top, and don't subtract the x's first, the y's on top. Alright, since I started with 0 minus 2 on top, down below, I have to start with the negative 6 minus 3, like that. Alright, if I have negative over negative, that comes out to be a positive slope. It's 2/9. That's okay. You can have a fractional slope, no big deal. Might come out to be an integer, might come out to be a fraction. Positive, negative, all of those are good slopes. Right, it's just calculating your slope. Let's see how it comes out in part B. For this slope, again, I like to start with the first y. It doesn't matter. Let's take negative 4 minus 2. That's on top. Then down below, I'm going to take a negative 3. If I subtract a negative 5, when you subtract a negative, that's like adding. So you'll see me put a plus there. So yeah, I took this first negative 4 minus 2 on top, down below negative 3 minus a negative 5. That's why we were adding 5 down there. Up top is a negative 6, down below is a 2. This comes out to be a negative 3 for my slope. Alright, just like that. If you calculated your slope and you came up with like 1 minus 3 on top, then down below you had 4 minus 4. So that's a negative 2 over 0, which is actually undefined. Right, that'll be a special kind of line, and I'll show you in a minute. Sometimes slopes do come out to be undefined. That's okay. If your x's are equal, that's what's going to happen. Right, you'll be subtracting two equal numbers, which will give you 0. Down below, that'll be undefined. If you have a 0 up top, that's okay. Your slope can be 0. Can be 0, might be undefined. Let me erase this over here. Alright, but just know that can happen, and it's okay for your slope to be undefined. Alright, we're okay with the time. I think I'm going to go on to this next page. Yeah, looking at positive and negative slopes. Let's get through this. I'm just going to sketch these, make a couple sketches, about 4 of them. Here's the first one. When you're looking at positive versus negative slopes, what you want to do, all these should be straight lines. Go from the leftmost point of your graph, go left to right. If it looks like your pencil or your finger's going up, this slope is positive. Alright, that slope is positive. If the line is going up, it has a positive slope. So, conversely, again, you have to start at the leftmost point of your graph and follow it. Can't go the opposite way. You always go left to right. Right, if it looks like you're going down, this is a negative slope. Alright, here are the two special cases. If we've got a straight horizontal line, this slope is actually equal to 0. That is okay. That's totally fine if you calculate a slope, or if you have a flat line, a horizontal line, straight horizontal line. The slope will always be equal to 0. That's because your y values are all the same. So you're subtracting two numbers that are equal on top over a non-zero number. The only other thing that can happen is if you have a straight vertical line up and down. Here you want to say the slope is undefined. You don't want to say no slope, because no slope somehow sounds like maybe the slope is 0, but either say your slope is undefined or your slope is equal to 0. Undefined for a vertical line, that's because here all the x's are the same. Your y's would be different. All your x's are the same, so down below you're subtracting two numbers that are exactly the same, so that's how you get a 0 in your denominator. Slope is undefined. For a straight vertical line, horizontal line, the slope is equal to 0. Alright, but going left to right, if it's going up, that's a positive slope. Left to right, if it's going down, that is a negative slope. Alright, I think I have time to, again, these, I'm actually limited to 15 minutes on this particular software that I'm using. Almost there, I got a few more minutes. Let's talk about horizontal lines, what their graphs look like. I just sort of sketched one up there, but they're flat, just like this, and the equation of a horizontal line, very important, y equals a number. Notice that there's no x in this equation at all, it's just y equals a number, and it's going to cross the y-axis at the point 0b. Alright, so whatever that number is, that y equals, find it on your y-axis. You can either put a point there or not, doesn't matter. But make sure you draw a straight horizontal line through there. You don't have to label that point if you don't want to. This is just y equals whatever that number b is. So for a vertical line, the way I have it drawn here, a is a negative number, but that's okay. Crosses your x-axis at the point A0, and it is a straight vertical line. But notice the equation of it, x equals a number. So what you need to take away from this is that the equation of a vertical line is x equals a number. You find it on your x-axis, whether you put a dot there or not, it doesn't matter. Just make a straight vertical line up and down through the x-axis at that point. Alright, straight up and down. That's x equals a number. If it's y equals a number, that's the equation of a horizontal line. Find that number on your y-axis and then draw a straight horizontal line through it. Right, those are horizontal and vertical lines. Let me graph these two very quickly and then I'll stop this video and we'll go on. A quick example of these two. Here's my graph for A. For x equals -2, first thing you need to know, let's just put a little scale on here. Doesn't have to be big. You don't have to make a big Cartesian coordinate system for this. Alright. X equals -2. X equals -2 right here. And what you need to know is that x equals a number. That is the equation of a vertical line, which we just talked about. So we found x equals -2 right here on the x-axis, so you just have to draw a straight up and down vertical line. Now put arrows on there so it doesn't look like one of the axes, okay? That's the answer. This is the equation of a vertical line right there at x equals -2. Let's do b very quickly before I run out of time. Put a little scale on each one of these. 1, 2, 3, 1, 2, 3, 2, 3. Alright, 1, 2, 3. Y equals 3 up here, and that is a horizontal line. Yikes. So you just draw it just like that. Stick arrows on it so it doesn't look like the other two axes.